We're now going to talk about how to implement a fair semaphore via the specific notification pattern. And to do that, we'll first talk about what is a fair semaphore. So if you have a fair semaphore, then threads that call acquire on it will have to wait in, first out, or so-called FIFO order. And in fact, if you think about the way that Java semaphores work, if you recall, there's a Boolean you can pass to the constructor of Java semaphore to indicate whether you want it to be fair or unfair, or haphazard, as we might say. And FIFO ordering in the context of this applies to internal points of execution within the semaphore methods, like acquire and acquire interruptibly. And what this means is that one thread could actually invoke acquire before another, but it might reach the ordering point after the other thread. And I just pointed out because the subtleties here are very, very pernicious, and it really has to do with when things go to sleep on locks. That's really what's on internal locks. That's really what's important. A good example of this would be Michael Phelps' famous win in the Beijing Olympics a number of years ago, where I think it was Milorad Kavik looked like he was going to touch first, but then Michael Phelps got his fingertip there just before the other guy. So even though it looked like the other guy was going to get the first, he beat him when ultimately they looked at the photo finish, as you can see here in this picture. The specific notification pattern provides an effective model for implementing fair semaphore semantics. And again, take a look at the link here, especially listing 3, to see how it all works. So what we're going to do after, now that I've kind of given you a little tour through what a fair semaphore is, which should hopefully be a refresher based on our earlier discussions of Java semaphores, now we're going to be able to turn our attention to how to visualize a fair semaphore implementation using the specific notification pattern.